Guys, please go on mute. Okay. So good morning, everyone. I hope you enjoyed yesterday's session, and we are doing some just recap of yesterday's session actually, because the people can be aligned with that of yesterday's class, what we have done it. Okay. So we started with working with unstructured data. Working with how to work with unstructured data, USD. Let us take an image, and after serial operations, how it is transforming, how it is being transformed and able to predict. Here we have seen the operations such as convolutional, padding, max pooling, stride, flattening, and fully connected layers. Right. Now we will go now we will go in a deep detail of convolutional is a process of it's a feature map generation, feature extractions from an image. Okay. So when you do the convolutional operation, my image gets shrinkage, or there is a data loss. What we are doing? We are using what? So padding. Padding will come with two flavors. One is valid, another one is same padding. Valid means 6 by 6, 3 by 3 is resulting 4 by 4 is valid. 6 by 6 convolving with 3 by 3 resulting 6 by 6 is the same. This is n minus f plus 1, n minus f plus 1. This is also n minus f plus 1, n minus f plus 1. Okay, this were the two things will happen in padding, and this stride of it's a 2 by 2 matrix. We convert we stride will give you how fast to scan the data, how fast we can scan the data. This was the stride, and again we have something called pooling to downsample the data. While downsampling, we are extracting features that are correlated to each other. This point is more important. Then finally we generate a map, feature map, feature map that is two-dimensional. We wanted to transform that into one-dimensional to feed to the deep neural nets. So we know that convolutional process is two-step process, two stages. One is front end, another one is back end. The front end will do all serial operations. It will be given to the back end to the classification or predictions. This is the whole story on convolutional. Ankur, is this fine? Guys, anybody need any doubt here? If you have any doubt, type in chat window. Ankur, is this clear? Anybody having doubt in this? Prasad, Shweta, Ankit, Himabindu, Meenakshi. Okay. So today's very important topic for anybody's deep learning career. Very, very important, very, very essential, how to tune your models. Without knowing this, if you know neural networks or if you know RESTnet, you know advanced architectures, nobody cares. One of the most important aspect to the deep learning is how do you tune the parameters. So, my question to you, what are the problems for machine learning? The major one problem is overfit and underfit. Can anybody explain overfit and underfit?
Hello, sir.
Yeah.
Actually, in the overfit, the data is fully fitted. Means there is no any remaining point that is not fitted, and in the underfit, the data is not fitted correctly, or it is
Who
less
is
fitted.
it? Hash?
Yeah, yes.
It's a completely wrong hash. Okay. So there is a two concepts is making the problems to the world of community of computer science is a overfit and underfit. Like so in generally when you take the data, we split the
Uh,
data into two parts, right? What is the two parts?
Test and train.
Train and who is this?
Aniket.
Prasad. Okay, Prasad. Like and my model is able to train able to perform well on a training data set and failing to generalize. Right on this will lead to the overfit. Okay, I'm coming here. What is the overfit? I'm trying to explain you. See, I'll tell you the example. एक छोटा सा बच्चा है, student है. He is able to do net practice properly. When it comes to the final match, international match with Pakistan or Australia, he is failing to select these shots. So what is happening in the D course? He is failing to generalize. Failing to generalization. The failing to generalization will cause the overfitting of a model. Ash, am I making sense?
yeah, yeah. Yes, sir.
Clear?
Yes.
It's not about something got fit and something was not fit. ऐसा नहीं होता है कि there is no something concept called people will say overfit means not fitted. Not like this. How your system is able to generalize the data. How your system is able to perform on unseen data. Like अभी कोई new data आते हैं, how it will able to act. That is what matters of the overfit. On a controversially, on a reverse front, underfit. We will see the underfit.
Right, sir.
अभी तो बोलो underfit. What is the underfit? Now we have seen that overfit performs well on a training data and fails to generalize.
Underfit
That is
is the opposite of that, right?
underfit.
Perform poorly on training and well on the test data.
No, that is what perform poor at
Less data.
training and also fails to generalize on test data. So these are the two problems. One problem with hyperactive kid. School time he reads well, and final exam he fails. Hyperactive. One is dull student. He do the both the same thing. Class exams he won't read and he won't perform, and even he will write. He will pass. Here also he will pass. That is not the accurate, right? That is not expected. That is what two conditions for either it could be machine learning or it could be a deep learning approaches. Guys, everybody clear on this overfitting and underfitting, or any questions on it?
No, all clear, sir.
No. We wanted to take it from everyone's because this is what the basic fundamental of any machine learning or deep learning design. If you don't understand this concept, you cannot build any application. And you build an application, you feel that it's a good model, but you don't know what is happening with what is the accuracy and the test data, and what is the accuracy and training data. So everybody clear? Okay, what is meaning of finalize to generalize? Okay, like if you wanted to see, if you wanted to system generalize means, see, the whole process of machine learning is generalization, right? For unseen data, see, okay, now it is coming to the generalization part. So machine learning is the process of learning. We learn the data, learn the data, learn from the data. What learning? Learning will lead to understanding of a patterns. It improves the better generalization capabilities. Capabilities on unseen data. Right. Now I'm able to, like, let us take an example. What is a better generalization? Generalization. Let take a student of class 12th. When he is preparing for IIT, he reads entire book, but when he sits for final exam, here we call this as unseen data. He will not get the same questions whatever he learned, right? He will get a new set of questions, but he is able to answer answer all the questions. How? Reason is the learning is leading to understanding of a pattern, and that made him to generalize. Okay, this question, okay, this is the method I need to understand. Then able to answer it. Answers. Satya, am I making sense?
Yeah. Okay.
This is what whole story behind it. Okay, guys, clear, right? Right, what is happening in the learning process now? Setting up your machine learning or deep learning application. When you're training a neural network, you may need to take the lots of decisions. How many layers in a neural network? How many hidden layers? What is your learning rate? What are the activation functions? So these are the foremost. I could say this is the very important phase of designing any neural network applications. It's not like that I have built a cat versus dog classifier. Okay, I'm good. I know how to. It's not about things. The whole story is this: when neural network is being done, how many layers we need to use, and how many hidden layers, and learning rates. We have discussed about the how many layers in the neural network. How do you choose the neural network? And for the first question, wrote down this. There is a no thumb rule to choose the layers. We take the random data and we understand model performance. And one thing is, more layers, model able to learn, model able to improve or learn. This is what we concluded in the previous classes. And we have seen the importance of learning rates. How fast model able to learn. The learning rate parameter. Where do we see the learning rate parameter? Yes, learning rate parameter. Learning rate parameter. Yes. Okay, optimization algorithm. So what is learning rate? Step action gradient. Huh. It decides how to choose how your model to run. Okay. So we are going to talk about training data, dev data, test data. It's a development. This is called a validation set. This is called test set. See, broadly our data is going to classify into 3 areas, not 2. Train, development, and validation. This is called validation set. This is called a test data set. The data you have on curve for some portion of to be a training set, and some portion of data you hold out for the cross validation. And sometimes it's also called a development set, and it is just going to call as a dev set. So you might carve out for some final portion to be in a test set. We are taking our data to be 3 chunks, and this is called a training, this is called validation, this is a test. Ideally, if you are going this way, this is not ideal split. 60, 20, 20 was your expected split and a data. Expected split and a data. Now you see. Deactivate few neurons model randomly. Learning rate. Ravi, it's not that way. Not at all. Learning rate is nowhere related to deactivating of neurons. Correct yourself. Right. I said right. Let us keep this as a. Basically, if you don't have this one, I'll have this one, 70 and 30. If you have this one, I'll make it as a 60, 20, 20% of the split. The thumb rule I would encourage to follow to the case to make sure that dev and okay. The major
Suresh, I have a question. Okay, till now we have seen train and test data only, right? So what is that dev and validation thing?
Dev and validation is the same. We will see this one, Satya. We are doing the validation, that's it. Validation that we will use that. Okay. The major thing is that we cannot have validation set and test set out of other group, or that is the reason we call it as an other distributions. The data should be drawn in the same distribution, drawn from same distributions. That's where the word comes data leakages. We will talk about this in the future classes. Okay, what is bias and variance? What is bias and variance? Anybody? What is bias and variance? Okay. There are two more concepts here. So one is bias and the one is variance. Bias is the error between actual to predicted value. This is related to the bias. What is the variance? When we change the data, how much system showing a variance, the error differences, how performance, that is called variance. Bias and variance is one of those concepts that are easily learned but difficult to be mastered. Even though if you think the bias is this, underfitting leading to high bias, overfitting, high variance. These two are very important. High bias. So imagine underfitting means what? It's failing to generalize. So there will be a high error rate, right? High error rate. Whereas high variance for a test set 1, it is having some generalization. Test set 2, it is again some error, some different performance. Test set 3, the variance is will estimate how your model is responding when you change the data. When you are changing the data. So now you can understand underfitting is having the high bias. High bias, we say that the data is underfitting. If you are incredibly complex classifier, maybe deep neural network or neural network with all hidden units, maybe you can fit the data perfectly, but does not look like a great fit either. So this classifier is called high variance. High variance, this lead to overfitting. Overfitting. Overfitting means failing to generalize. Failing to generalize the data is overfitting, and underfitting is related to high bias. High bias is nothing but huge error rate. So when you will get a huge error rate, when you are unable to generalize in the both the case, your underfit comes in the when you fail to generalize in both. Guys, any doubt here? I'll explain you and we'll go forward. Yes, very small change of there will be a lot of change in the input, then change in the output. Any doubt of this one? Bias, variance,
No, sir.
high variance, low variance.
All clear.
Okay. Mahita, Kavya, Ganesh. No. This is what very important coming slides. Okay. Training is set error is 1%. It meaning of that 98% accuracy. 99, sorry. And dev set or development data set, it is 89% accuracy. Right. So 99% accuracy and 89% accuracy. What is happening here? Is it overfit or underfit? I need participation, guys. Then only we can make the good learning. Ask क्या हो रहा है इस पे? Overfitting हो रहा है.
It's overfitting.
Everyone? Shweta, वो underfitting है? He is able to good at training set. He is able to perform on a training set. He is failed on the test set. So okay. In this particular scenario, able to do good at failing at test. So this lead to area of overfitting. Shweta, is it clear? Now you tell me now. My training error is, my accuracy is, sorry, 84. This is 85. So what is happening here? Let us assume my training data set, my training accuracy is 55. My test accuracy is 56. Is it overfitting or underfitting?
Underfitting.
Because there is a not performing and there is a huge error in training. Also a huge error in
Development.
Test.
In this case, we can humans will assume actually that roughly that 0% of the error, because the 1% is less, minimally less, but then it looks like that algorithm not even doing well on the training set. So if it is not fitting on the training set, data seems to be well, then it leads to the underfit of this algorithm is having high bias. This is what very important concepts of overfit and underfitting. Now you tell me now this question. My training accuracy is 85. My test is 70%.
Overfitting.
Huh?
So it's underfit.
Overfit or underfit?
Overfitting.
It's underfitting because test error is more than training error.
Okay. So if you have 0.5 training set error and 1% of the dev set error, then maybe you users are quite happy that you can have one error. Then we just have low bias and low variance. It's not that true. We should have the proper fit of the model. There should be a trade-off between Guys, go
Suraj
on
bro,
mute.
is more.
There should be a trade-off between bias and variance. We need to see that one. So overfitting, underfitting. You can see the pictures. He is smiling. He is crying. But our model should be like there should be a trade-off between bias and variance. Okay. Now, if you are the first and foremost, this is what very important, guys. If you are not understood this concept, you raise a flag. I'll explain you the concept here. If it does have high bias and does not fit in the training set as well, so some things you could try to pick. This is called you are a underfit. The model is underfit. I will show you the underfit models today, right? And you increase your hidden layers. What we need to do? We need to increase hidden layers, or you could train for longer time. What is the solution for underfit? Write down your notes. Solutions for underfit. One is hidden layers and longer training. This is the basic fundamental. Maybe run the train for longer or try something advanced optimization algorithms. What is the optimization algorithms?
Gradient descent.
Okay, yes, some different approaches. Whereas getting a bigger network almost happy to help the training, and training longer does not help, but certainly it never hurts. This is only one fact that your training longer will help you, but not that much extent. Maybe like 5% something. First point you understood, right? Hope you understood the first point. Clear about this? For underfit?
Yes, sir. Yes, sir.
If you are clear, type underfit. Okay. What is the basic thumb rule? Underfit, you add the layers and you train them more. Okay. Now, if you are having high variance is what? Now, high variance is what?
Underfit.
Yeah, overfit, man. I'm going back. High variance is overfit. Guys, high variance is overfit or not?
Overfit.
Yeah. Overfit, high variance. Right? Fine.
Yes.
Ankit, don't get confused. Huh? These are some things. Now, if it is an overfit, what we need to do? We need to get more data. And then there are the recipe for this. Get more data, and we can try optimization algorithm, regularization, regularizations. So, what are the regularizations we have? L1 regularization and L2 regularizer. I believe you know this L1 and L2, right? In machine learning, you got the L1 and L2. Lasso and Ridge regressions.
Norm 1 and Norm 2, right?
Norm 1 and Norm 2. So L1 and L2. If you are actually having the high bias problem, getting more training data is actually not going to help, or at least it's not most efficient things to do. So bigger network, reduce the bias, more data, reduce the variance. This keep these 2 points in, like, write down this like a bullet points like this. For this high variance, write this problem. For this solution, write this. This class, I could say, it's like Andrew Ng's deep learning course. One of the course, like better performance or something. That was, I have summarized everything from this, and so I have prepared this slide actually. Guys, so far are you able to understand or not?
Yes, sir. Fine.
Prasad garu, clear?
Yes,
Yes.
sir.
Yes, clear.
Okay.
So what to do in case of high bias, sir? Can you please explain? In case of high bias, what is the solution?
This was the solution, right? Try to pick a network which is having more hidden layers.
Okay, got it. I got confused in the high variance, high bias. What exactly?
So overfitting, high variance. The first thing you should try for high variance is try with regularization. Try with regularization. First thing, high variance, try with regularization. I'll take other colors. You should try with regularization. Another way to address the high variance is get more training data. But you cannot always get more training data, and it could be expensive to more data. But adding regularization will help you to prevent overfitting or to reduce error in your network. Write down this point. This point is very, very important for the regularization perspective. Very much essential. Right. But adding the regularization will often help us prevent overfitting or to reduce the errors. Now, how regularization works? You know, right? Regularization, adding the lambda parameter, right? Adding the, you just go and try to understand what is L1 and L2 regularizations. And issues of regularizations, issues with regularization. What L1 and L2 will do? Naveen, can you answer? Naveen, explain them.
Yeah, sir.
Yeah.
Regularization means yes, sir, we are regularizing the constraint value. Parameter values of unnecessary independent variables.
Okay.
Means we are shrinking the coefficient values of unnecessary independent variables.
Okay. Okay. Which one makes the zeros? L1 or L2?
Mostly L2, sir.
L2.
Sorry, L1, L1.
L1.
Lasso.
Lasso will make you the data to be sparse. So it will having the more zeros. If you have L1 regularizer, it will not gonna help. Write on this. This point you highlight in your thing. This will not help out. This will not help. This is what L1 regularization issue. If you use L1 regularizer and the weights, the weights will end up being sparse. Sparse means you will have the more number of zeros. More zeros. So it means that the vector weight vectors having the vector W. So W is a weight will have the zeros in it. So there is no use. L1 regularize make your model sparse helps only little bit, or I would say it won't help. I'm saying that with my experience of building enough neural network applications, it didn't help us. In a book, it was telling that it has very little bit, but it didn't help at all. For my experience, I have built lots of deep learning applications, which we are also building, which we are continuously working on products. So it's not helping. So L2 is most common type of algorithm. What is meaning of that? Your weights will never be 0. It will becoming closely to 0. Closely to 0. This will help us to train the model in a better way. We will see. Okay. Why regularization reduce the overfitting? This was very bigger classes, sir. This were big concepts for machine learning or any deep learning. If it is a normal training institute, the people say overfit and underfit, because here we are sharing with very high intensive knowledge. This is very knowledge sharing sessions. Should get benefit out of it. Waking up in the morning and we should be like worth of it. L2 regularizations said that weight matrix W to be reasonably close to 0. We are not making weights to be blue. I'll take a blue. So close to 0. It's not equal to 0. It is very close to 0. And if that is the case, this much be simplified network and it becomes much smaller network. Another trial you can do using TANH also. The activation function you can use TANH also. After completing this series of lessons for 1 month, I'm surely can tell you that you can challenge any interview in the world and you can ask why. I surely say that I'm the right. You can say that you have that. We will get that much of confidence. We will gonna see multiple applications, building of multiple applications and multiple concepts. I'm sure that I'm gonna teach you the best. That's it. That is the only thing one I wanted to tell you here. That's it. Please, if you are not understanding, let me know. Now, guys, understood till this point? L2 regularization. Sagar, we are coming to that point, Sagar. Data augmentation, we are coming to that point. Everybody got understood of L1 and L2 regularizations?
Yes, sir. Understood.
Everyone. Ravi, Vaibhav, Kavya, Ankit, Ankur, Prasad Garu, Himabindu. Am I going faster? Am I going very slowly?
Yes, the speed is okay.
Okay. Now we are coming to the dropouts. This is what very important. We often see in the deep neural networks. We use the dropout.
Suresh, there is some background noise. If you record this one, then okay, now it's free. Still, I hear there is something going on in the background.
Wait a second, I'm gonna mute all. Everybody has unmute, Satya.
No, but I hear a lot of noise actually. Somebody is talking in the background, or something is running in video or audio, something.
No. It's like outside. Guys, go. Please try to ensure that your things are. What is the difference between major and okay? Guys, please help out and close your doors. Most probably. Okay. Kavya is asking what is the difference between bigger network and more data, right? So when you talk about Satya, now it's gone, I guess. So bigger network and more data. Bigger network and more data. If you have layers, if you increase the hidden layers, how the neural network input, hidden layers, output, right? Initially you have hidden layers of 3, you change it to 5 if possible. So that makes your network bigger. Or else, I have 100 records of the data, you increase the data to 2000. Right. Kavya, is it making sense? Yes. Okay. Now, the most important factor for deep learning is to reduce this overfitting. The more important useful concept is called the dropout. What is this? Dropout. Takes a reg. I have this. This is my network. I have input layer, and I have my hidden layer 1 and hidden layer 2 and hidden layer 3, and I have my output. This dropout sometimes can be referred as regularization in deep learning. Whereas in machine learning, we need to explicitly mention L1 or L2. Whereas here, you don't need to mention anything. That if you mention the dropout, that acts as your regularization. So what will happen? Dropout, you are removing the connections. Dropout will do what? Remove the connections which is not adding any value to network. It means that the weights at these nodes weights not being updated. When this will not update, when you are having after activation function, when you multiply with inputs to weights, when it becomes 0, there is nothing to activate, right? So that was the reason the deep learning will deactivate those connections of internally, and it removes the some of the connections. Dropout will remove the connection automatically. So you don't need to read it, right? So this I don't need to go this way. So I directly go. Like I'll tell you an example how dropout works. It prevents the overfitting and provides the way of approximately combining the exponentially many different neural network architectures efficiently. This this concept is helping most of the applications. Most of the applications. The term dropout refers to dropping of the units in a neural network. By dropping of a unit, we mean that temporarily removing it from the network along with all its incoming and outgoing connections. The choice of which units to drop is here the random. Here dropout is in a random variable. Random variables. Effect of the implementing dropout is that strings the weights and does the same of those outer regularization that help the preventing of overfitting. To summarize, it is possible to show that the dropout is having the similar effect to the L2 regularizations. Dropout will be equivalent effect of like L2 regularization. Regularizations. Clear? Clear or not clear? If you are clear on the dropout, type dropout.
Sir, do we have any mathematical expression for dropout?
Mathematical?
Expressions for dropout means how it work exactly?
I'll share that links, okay?
Yes, sir.
Clear about dropouts? Okay. The many of the first successful implementations of dropouts so that computer vision the input size is big and inputting the pixels will all never be enough the data. So overfit dropout is frequently used for computer vision. Dropout is a regularizing techniques. It prevents the overfitting. Why we use the dropout? We use dropout for overfitting. Data augmentation. Another one is data augmentation. Let us say that we are fitting of a cat classifier. If you are overfitting, you need to get the more training data. But getting more training data is expensive. Sometimes just you cannot get the more data. So what we can do is we can do the data augmentation. So this is what I have input image. I have done the augmented. This picture 1 and picture 2. I can tilt this image or I can zoom this image. Whatever the way I do, I get the other pictures. Other picture. This is what the data augmentation will help us solving overfitting. The minor changes such as flips and translations or rotations, our neural network would think these are the distinct images anyway. This is the major important point. This can be inexpensive way to give the algorithm the more data, therefore sort of regularizing it and reducing the overfit. Image data generators, we have the like shift, shear, shift and scale, rotate and scale. This how I am creating the I'm generating the data from a given existing data. Existing data. We are adding to the new data. Okay. One more concept called early stopping. What is meaning of early stopping? Anybody? Meenakshi, what is early stopping?
As soon as we see uh, the accuracy for training set is going down, then we have to stop and check.
Sorry?
I mean, whenever we see that accuracy of training test data set is going down,
Hmm?
then we have to stop there and check what is wrong.
Okay. Okay. I will say if there is no improvement on the further accuracy. So I have training for 10 epochs, my accuracy is 20. For next 15th accuracy also I have 20 only. So there is no need of training your model, right? We need to stop it when there is no improvement in the accuracy. That is what we refer that as an early stopping. So now you see, early stopping is a kind of cross-validation strategy where we keep one part of training set and one validation set. When we see that performance of validation set getting is worse, we immediately stop the training the model. This is known as early stopping. This will be known as the early stopping. Training of neural network is challenging. When we are training a large neural network, there will be a point during the training the model stops generalizing and start learning statistical noise during the training set. This is what happens for the your model. This is the biggest issue for your neural network. This is the biggest issue for your neural network. This overfitting of the training data set will result the increase of the generalization error, making the model less useful, making the predictions on a new data set. This leads to this issue. Right? Clear, guys, about what is happening on the early stopping? Not only stopping whenever the not increasing. So whenever your accuracy is not being increasing and your model is still trying to learn, it will learn noise only. It will learn noise only. There won't be any there won't be any improvements. There won't be any improvements. This will lead to the overfit. Hope everybody is clear on early stopping. It's not about only the stop whenever there is no performance. Why we are not why we are stopping that there is no improvement, because it tries to learn unwanted noise. So this noise will lead to the overfitting. So that good way we can solve this overfitting issue. The other technique is batch normalization. What is batch normalization, Naveen? What is batch normalization, Naveen? Left. Anybody, what is batch normalization? Sagar?
To improve the speed.
One second, one second. Sagar, no, sir, it is reverse. What is the concern, Sagar? Difference between more data and bigger network and more data?
It makes the small packages that can be used for standardization.
Hmm. Ravi, you have pinged this. Okay, okay. Sagar, what is this? No, sir, it is reverse. Here I could see some message here. What is the doubt here for you?
In that architecture, sir.
Sorry?
In that architecture,
Wait,
it is shown that
huh?
in the dropout regularization.
Huh?
Here it is you have written input from the first. Actually, these are new. These are firing from the in this direction. So this is input layer, and final one
Okay,
is
okay.
output. But you had
Okay, okay.
drawn in,
Maybe. Oh, I didn't see the direction. Fine, fine. Okay. You mean to say here there should be an input. From here we are firing the neurons. This is what my output. Okay. Here is my